All right, let's go and get started with review exercise 71. Review exercise 71, solving 8 different equations, but you're only going to give positive answers. Only giving positive answers. So if there should be a negative answer, we're going to ignore it. Just like we would in geometry, where you can't have negative lengths or negative angles. So we're going to practice here ignoring any negative answers you might get, only positive answers. Exercise 71, you may want extra paper. You may begin. First one to finish, if you would stand and keep track. right, for sake of time, I'm going to put your pencils down. Did you finish, Shane? All right, anyone else finish? All right. Well, Ethan was the first one to finish, so Ethan, go and give us your answers to that top row going across.
1.
1, good.
8.
Yep.
6.
Yep.
And 3.
Ooh.
Oh,
All right, Jamie, did you get the first 3 correct? 1, 8, and 6. You did not. Anyone else get the first 3 correct at least? All right, what did you get for the 4th one there, Audrey? Ooh, that is not correct. Anyone else get that last one on the top row? Pardon?
24.
Should have been 24. All right, we'll take a look at that in a moment. What about on the bottom row? Jamie, what did you get for the first one on the bottom row?
4.
4, good. For the next one?
9.
And again, both of those technically would have been positive and negative, but again, we're ignoring the negative values here, so only 4 and 9. For the next one?
4.
No.
1/4.
1/4 is correct. And so therefore for the last one we would get
1/9.
1/9. I want to take a look at a few of these. Unfortunately, no candy today, but just missed that one, huh? All right. Let's start by looking, though, at the last one on the top row, because how many did get 24 like Quentin? Okay, only a couple of you. Remember, if you have fractions in an equation, there should be this feeling of loathing and hatred.
Yes, absolutely.
Hate the fractions, right? So we multiply everything by the LCD to get rid of the fractions. Now the LCD here is 6, but everything, even if it's not a fraction, remember, gets multiplied by the 6. Here the 6 and 3 would cancel to give you a 2 times the 2 and the x to get class 4x. Obviously 6 times 1 is just 6. Here the 6's cancel to leave you with just 5x. And then here again, don't cancel to get a 2. They multiply, because that's over 1. Nothing cancels. You get negative 18. So if you cancel and got a 2, is that what happened?
I skipped the 5, 6.
You skipped the 5, 6, okay?
I just went straight to 3.
So here we'll pull a little bit of a double switch. Send the 4x over as a negative 4x to get x. Send the 18 over as a positive 18 to get not 12, but 24. Questions on it now that we've seen it? I remember doing this from past years. Were there any questions on the first 3? I know, Jamie, you mentioned you didn't get them all correct. Any questions on any of the first 3 from you?
The first one?
The very first one? Yeah, pull a double switch here. So send the 2x, because it's the little x, remember, get rid of it, move it over as a negative. At the same time, send the 5 over as a positive to get 1 equals 1x, or just x equals 1. All right, any others? So the first, second or third problems on the top row? Second or third on the top row? Anyone you see worked?
Third.
The third one? Remember with decimals, we hate those as well, Jamie. And technically decimals represent fractions, right? Tenths, hundredths, thousandths. So this is technically a denominator 10, denominator 100, denominator 10. Well, denominator 100 would be the LCD, but denominator 100 basically could be eradicated by moving the decimal twice, right? Multiplying by 100 just moves it twice. So the way I taught it is find the ugliest decimal, which is the 2, move it everywhere 2 places. Well, here 1 comes after the 2, but then the x has to get filled in with a 0 to make it a 20x. Here, both places just give you a 15, and then the x. And here, the 1 place is the 1, then the next adds another 0 to get 210. We'll combine our x's to get 35x equals 210, and when we divide by the 35, we get 6.
Yes.
Yes, x equals 6. All right? Now, on the bottom row, the first 2 we all should have been good with. Everybody good with the bottom 2?
Yeah.
But let's take a look at 1 over x squared equals 16. There's 2 ways to approach it. The best way, perhaps, is just put the 16 over 1 and turn it into a proportion. And how do we solve proportions, class? Cross multiply. So here, that would give me a 16x squared is equal to 1. Divide away the 16 from both sides to get x squared equals 1/16. Then take the square root in the incomplete quadratic to get x equals positive negative 1/4. Of course, we're ignoring the negative answers, and that's how we get 1/4. The other way is this. 1 over x squared equals 16. Well, what squared equals 16, class? 4 squared. But this is the reciprocal of something. So I need the reciprocal of 4. I need 1/4. And that's the other way you could have thought it through as well, instead of doing the cross multiplication. And that's the same process that would have been used on the last one to get 1/9. Questions at all on exercise 71? A little bit harder. right? Some harder equations there. Do they make sense now? Is this a good algebra review for us? All right, well, let's get back to geometry now as you pass those forward. And we have been practicing with locus problems. Again, a locus, what is a locus, Genesis?
It's a condition that it's something that satisfies a certain condition and
Yeah, a group of points, more specifically, a group of points that satisfies a given condition, or perhaps that group satisfies multiple conditions. And in fact, that's what we've been working on lately, has been multiple conditions, right? We call this a compound locus problem, where we'll have two or more conditions, two or more loci, and the idea is, well, for one locus, there's generally an infinite number of points. For the second locus, I was meditating, making the sneeze go away. All right, for those of you who watch a lot of football, you get a State Farm commercial. All right, anyway, you remember that one? So there's a fire in the bathroom? Yeah, and the towel catches on fire, and the guy's like, oh, you're a State Farm guy, do y'all take care of fires in the bathroom? How could there be a fire in the bathroom? Well, maybe somebody accidentally got one of the towels on fire. Somebody? Weren't you the one just in there? No, I don't go to the bathroom. How don't you go to the bathroom? I meditate, make it go away. Anyway, so I was meditating, letting the sneeze go away. Anyway, anyway, I digress. Let's get back to geometry. So locus, yeah, that's what we're talking about. We're talking about loci. And so a locus, remember, we could have two loci, right? One locus, of course, would have an infinite number of points. Could be a straight line that's composed of infinite points. Could be two straight lines, which of course would still be infinite points. You see, wouldn't it be double infinity? Double infinity is still infinity. All right, could be a circle that's composed of infinite points, whatever, okay? And then take another locus of infinite points. But you see how many times those two loci will intersect. And the number of possibilities in the sketch to back it up is kind of what we've been going for with these compound locus problems we started looking at yesterday. Now, two important qualities of a locus, Kendall. First of all, a locus must be inclusive. You'd better think of every single possible scenario there is. But a locus is also, Audrey, exclusive. You better not put a possibility that ain't there, right? You better not put any more points than are actually truly satisfying the conditions. So we have to, in other words, get it exactly right, okay? Inclusive and exclusive. Now, you had two opportunities for extra credit last night, page 178, number 6 and number 7. How many attempted number 6 and or number 7? All right, you 3. Did you all do both 6 and 7? All right, if you would put your name on the paper, and we're going to have you all swap and check each other's. Okay, so if you would put your name on the paper, and we're going to have you swap with each other. So Quentin kind of be the middleman here and handle the arrangements. All right, just make sure you don't wind up with your own. And the rest of you, go ahead and do it with me. They're going to be checking answers already done. We're going to talk them through since we haven't done them yet. Page 178 in your textbooks, and have some paper out. And let's take a look at number 6. Go ahead and read number 6 while they're getting their stuff ready. Audrey? Never mind. While she's turning as well. Quentin?
Find all points that are equidistant from two given points and also equidistant from two given parallel lines.
All right, so the first locus we see, Quentin, is finding all the points that are
equidistant from two given points.
What is the locus of points equidistant from two given points?
Perpendicular to a line drawn from the two given points.
So you said if we were to draw a line between the points, it would be the perpendicular? A perpendicular bisector. Now that's very important, right? Because if you just said perpendicular, right, you're including points that don't belong and potentially excluding points that do belong. So specifically the perpendicular bisector. Okay, so there's locus number 1. Locus number 2, Jamie, was?
Also equidistant from two given parallel lines.
Now, does it tell me where the parallel lines are in relation to this? No. So, I mean, the parallel lines could be like something like this. And what's the locus of points equidistant from two given parallel lines?
The line that's equidistant from both sides and
You're using the word I used. Don't use my word.
midway between and parallel.
Good. A straight line parallel to the lines midway between. Something like this. So, if these are my two loci, At how many points could these two fundamental loci intersect each other? What do you think, Ethan?
One.
Okay, for instance, we know that lines just keep going infinitely, right? So here we see one point of intersection. Any other possibilities we can think of, Genesis, besides getting one point of intersection? Kendall, can you think of anything?
0.
How 0?
If you run it parallel to the line.
So if my parallel lines ran parallel to the perpendicular bisector, then the locus would also be parallel to the perpendicular bisector. They would never intersect, and I would get 0 points of intersection, right? Can we think of any other possibilities now, Genesis, now that we've showed these two? No? Audrey?
Infinity.
How infinite?
You can run them on top of each other.
Right, if you were to move this, so for instance, these two parallels were the same distance away on either side here, then their locus of equidistant, parallel midway between them, would actually coincide. So you could also get infinite points. So you could get no points, you could get 1 point, you could get infinite points. Now, is the paper you are checking, have all 3 of these, including a sketch for each of them? Check to make sure each one of the answers, 0, 1, and infinity, has a sketch showing 0, showing 1, and showing infinity. All right, Quentin, you said yours does. Whose paper do you have?
Jamie's.
You have Jamie's. Okay, so Jamie's good to go. All right, Audrey?
He has the
I know
the
mine.
answers, but I don't think he has something.
Not the sketches, okay. All right, Jamie, still
Not
checking?
sure yet.
Not sure. All right, let me see if I can find it.
For the infinity one.
So you see all the answers. Those are there.
Looking for infinity.
We see 1. I see 1 again. I see 1 again. I see none. Yeah, I'm not seeing the infinity on here. The infinite possibilities. So the answer's there, but not the sketch for infinity. All right, so Audrey, since it was your paper, does the infinity make sense how to draw it? Okay, all right, let's take a look at the next one then, number 7. And now that we're here, go ahead and read that for us, Genesis.
Find all points that are a given distance from a given line and are also equidistant from 2 given points.
All right, so for my first locus, Genesis, it was what?
All points that are a given distance from a given line.
All right, given distance, which could be anything, right? So I can change this distance, I can make the distance anything I want from some given line. What would be the locus of all points, a given distance from a given line?
The 2 parallels above and below
Or in this case, on either side.
either side of the given line.
So like a parallel on one side, like a parallel on the other side, like that? The one important thing that got left out, you got me 2 lines, that's true. They're both parallel, that's true. They're on either side of the line, that's true.
They're both the same distance.
Not just the same
But
distance,
the given.
the given distance away, right? So I've got to actually kind of figure this far and this far, and maybe even notate. Okay, there's my given distance in each case, right? So, so there's my first locus, and then what was the second locus again, Genesis?
And also equidistant from 2 given points.
Does it tell me where the 2 points are? So the points could be anywhere. The points could be like over here. And if they are, what would be the locus of all points equidistant from 2 given points, Ethan?
Perpendicular. You can draw a line between the perpendicular line, or the line between the 2.
So if I drew the line, it would be perpendicular to the line.
The perpendicular bisector.
There we go, perpendicular bisector of the line segment that would join the points. So there's my second locus. And how many points of intersection do we get here? What are you thinking, Kendall?
1.
Oh, I see. So like if we extended it, these two would end up meeting down here. So we get a point?
2.
2. Because if it extended, and it would, eventually would not hit just this one. If it intersects this one, it must intersect the other also. So no, I don't see that 1 is a possibility, but 2 points is certainly a possibility. All right, do we see any other possibilities here? Genesis?
Um,
Besides this line crossing twice.
Zero,
How 0?
if they were parallel to each other.
Right, so if these points were arranged in such a way, for instance, that when you drew the perpendicular bisector, it ran parallel to these other two lines, you could get no points, couldn't you? All right, any other possibilities you can think of, Ethan? Let's see here. Kendall, can you think of anything else before we go to those who already did it?
Infinite.
How infinite?
If a line was positioned to where like the perpendicular bisector and the line went on top of each other.
Right, if this perpendicular bisector locus happened to coincide with either one of these, now obviously it couldn't lay on top of both, right, at the same time, but it could lay on top of either one, and you still are getting infinite points of intersection, aren't you? So you could get infinite points, all right, anything besides 0, 2, or infinite. Let's go to those who've already done it. Did you get anything besides 0, 2, or infinite? No, because if the line crosses one, it must cross the other. If it's parallel to one, it must also be parallel to the other, so therefore none. And if it coincides with one of them, that would of course be infinite. Those are the only possibilities. So check the paper. Did your paper have 0, 2, and infinite, and is there a sketch to show each of those? You're saying yes, okay? And you had Jamie's, right? All right. No.
This one has 1 included with it.
Also has 1, which is not true. So does it make sense how he could not get 1? Because for it to intersect once, it must be non-parallel. But a line non-parallel to one of two parallel lines is non-parallel to the other also. So not the one. But Jamie got them really close on both of them, just missing a sketch once and then an extra answer on the other. And then Quentin, I didn't get a chance to see what your mistakes were.
I didn't have sketches.
You just didn't have sketches.
I had one sketch and then I just...
They were all up here?
Yeah.
We just got to make sure we put them on paper, right, to help back things up then. All right, questions at all from the rest of you who didn't take the time to do it? Questions? All right, go and exchange back then with your papers. And you're on page 178 already. Let's take a look at number 2. And let's have Jamie go and read number 2 for us.
Look at all points within a given angle that are a given distance from the vertex and also equidistant from the two sides.
All right. All points within a given angle. That's one locus, isn't it? That are a given distance from the vertex. That's another locus. Also equidistant from the two sides. That's a third locus. All right, so what do we do? What? Draw an angle. What kind of angle? Any angle. So pick one.
Oh, okay.
But you're right. The correct answer is any angle. It could be any kind of angle. Acute angle. All right. So let's go with an acute angle. And first of all, the points have to be within the angle. So points out here don't work. Okay, they're not within the given angle. None of those points work. Only points, of course, as lines extend, points in here would satisfy. Okay, but there's a second locus, and the second locus, it said, Jamie, was
Equidistant from the two sides.
Was that the second one? I think that was the third one. So first locus was within a given angle. Second locus was
Equidistant from the vertex.
This doesn't sound like one we memorized. Given distance from the vertex.
52.
Given distance, that maybe, from the vertex.
Circle.
We have done this one. Because this is a point, right? The vertex is simply a point. So don't let the fact that, but we didn't memorize given distance from vertex. Hold on now. What is the vertex? What's a point? Did we memorize given distance from a given point? Oh yeah, it is a memorized one. It just didn't word it like one. So yeah, we're going to get a circle with this given distance.
Where it is.
So now notice the points along this arc were the only ones that so far satisfy the first two loci, right? It's still an infinite number of points within that are in the arc. Okay, now not these points because those aren't within, okay? But all the points in here and none of the points out here or the points on the line. But there's a third locus. And the third locus, Jamie, is?
Equidistant from the two sides.
Equidistant from the two sides. Have we memorized that one, class? Yeah, what's that one?
Angle bisector.
Angle bisector. How many points satisfy all three loci?
0. 1.
1.
Oh.
Where the angle bisector hits the arc of the circle, right? So there's 1 point. Now that's if we do an acute angle. But what if Genesis had said obtuse angle? Well, we'd still have the little circle thingy, right? We'd still have the angle bisector. Would we get anything different? No. Picture it in your head. What about a straight angle?
No.
Right angle? Same thing. Reflex angle? So does it matter what kind of angle we draw? You know, in this case, drawing a different size angle doesn't make a difference. Sometimes it does, though, right? We looked at an example the other day, I think yesterday, where a different size of angle did make a difference. Here it doesn't. The only answer is 1 point. Questions on number 2? Let's take a look at number 3. Read this one for us, if you would, Quentin.
Find point in a given distance from two intersecting lines.
A given distance from a who?
From two intersecting lines.
From 2 intersecting lines. Given distance from 2 intersecting lines. So draw a couple intersecting lines in your paper. And let's go with this given distance here. Oh, well, I haven't memorized this one. I've done equidistant from 2 intersecting lines, right? That would be those angle bisectors. This says given distance from 2 intersecting lines. I haven't memorized that one. Now, if it had said a given distance from their point of intersection, I got this, right? That's given distance, given point, circle, but it didn't say that. It said given distance from 2 intersecting lines.
Go from the point and draw.
The only times we've done given distance have been given distance from given point and given distance from given line. I've never done given distance from 2 given lines, but you realize 2 given lines is merely 2 given lines. So let's take just this line. Let's call it line Q. What would be the locus of all points at given distance from just this line?
2 parallel lines.
2 lines, each parallel to the given line Q, and this given distance away on either side, right? So we go up given distance and go down given distance. Right? And so there's the locus of all points this distance from Q. Let's call this point A. What would be the locus of points this given distance from line A class? Same thing, except this line, right? So 2 parallel lines, each this given distance away, parallel to the given line on either side, right? So we would come up here, and we would come up here, and there's given distance, and there's given distance. So how many points are this distance from both lines? 4. This point is the given distance from both. This point is the given distance from both. This point is the given distance from both. And this point is the given distance from both.
But don't we have to add?
So we get 4 points. But let's think. What if my given distance had been really, really small? Like that big.
Okay.
Then what? Still would have been 4, wouldn't it? Okay, what if the given distance was really big? So, I mean, we're talking like way down here and way up here. They're still going to intersect 4 times. Is there any way to draw this so that they don't intersect 4 times? Could I ever get these to lie on top of each other, maybe? No, not if the lines didn't already coincide themselves, right? So the only answer, 4 points. We should take a moment to think if there's any other way to do it, right? You shouldn't just stop at your first answer because there may be more ways, but here, this really actually was the only way to do it. Questions on number 3. Do you see how to think a little outside the box? We could get easily locked in on intersecting lines and be like, oh, it's the angle bisectors. Wait a second. Given distance from the line. It's actually 2 loci. Given distance from line and given distance from line. Make sense? Let's take a look at another one. Number 5. Read this one for us, Audrey.
Locate all points that are given distance from a given line and also equidistant from 2 given points on a line.
All right. The first locus was? All right, so we give ourselves a given line, we give ourselves a given distance, and Audrey, we draw 2 parallel lines. The given distance away, well, you already said parallel. on either side, right? So it's not 2 on this side, but 1 on either side, right? So become a given distance, and become another given distance, and there's distance, there's distance. Okay, so there's my first locus. Second locus, Audrey. Right, equidistant from 2 given points, but it told me where I had to put the points. They have to be on the line. All right, so it doesn't tell me how close or how far apart. I can make them really close if I wanted to. I can make them far apart. Let's go far apart for a change. What is the locus of points equidistant from 2 given points, class? Perpendicular bisector. So, how many, class? 2. 1, 2. All right. Is there another way I could have drawn it? What if the points had been really close together? Still would have been 2. What if the distance had been really, really small? Would have been really big. What if the points have been like really far apart? Still 2. No matter how you draw it, because they force you to put the points on the line, you're only going to get 2 points. Okay? But think of all possibilities. Try to envision what if we change things up. Well, there wasn't a whole lot of changing up you could do other than changing the size of the distances here. Questions on number 5. Starting to get a really good feel for these.
Oh, yeah.
All right. Number 8 will be our last one together, then I'm going to have you try some on your own. Number 8, go ahead and read it for us, Ethan.
Find all points that are equidistant from 2 given parallel lines, and also a given distance from a given line.
All right. So, first locus.
Find all the points that are equidistant from 2 given parallel lines.
All right. So start with a couple parallel lines. And equidistant from given parallel lines.
Midway. Line midway between and parallel.
Good. Line parallel to the midway between them. All right. So there's locus number 1. And locus number 2.
Also a given distance from a given line.
All right. Now, does it tell me where my given line is? My given line could be like that, couldn't it? And my given distance could be anything, right? I could have a given distance that's like that big. All right. So, if I have this big of a given distance from the line, what's my locus going to be here?
Parallel lines that distance.
All right, and of course, here's that given distance, and here's that given distance, okay? And so how many points, Ethan?
2.
2. Because remember, this line just keeps on going, and so, yeah, 1, 2. All right, any other possibilities? What if the distance had been like a normal little distance here?
That is the line that's in the middle.
Oh, 0? Ah, so you're saying if this line were to run parallel to the other lines, that its distance may be, I don't know, something like that, then the loci would all be parallel. Everything's parallel, right? And it almost looks like the writing paper you had when you were a little kid in elementary school. And so, yeah, no points.
Infinity.
Infinite. How infinite?
The line coincide with the one in the midway, right?
Right, if one of these 2 lines were to coincide, so if maybe the distance had been just right, now of course we can't get both of the locus lines to coincide, but we could have gotten infinite points of intersection, couldn't we? Anything else? Could we get 1?
No.
No, because if one line intersects this one, then the other line has to as well. Could we ever get 3?
No.
No, because one line can only cross one line at one point unless it coincides. So you're only going to get 1 from this one, 1 from that. We can't get more. So, yep, 0, 2, and infinite would be our answers. Questions on this?
Easy.
All right, turn to page 184 now. Your turn to try some on your own. Page 184. And I want you to do number 2. When you finish, put your pencil down, and once most of you are done, I don't want to wait for everyone to finish, but once most of you are done, we'll go ahead and see how you did. Genesis. Got it, or just rubbing your eyes? You got it, okay. Kendall's got it. Audrey's got it. All right, let's take a look. Page 184, number 2 says, look at all points that are equidistant from the sides of a given angle. All right, so start with some angle. Equidistant from the sides, of course, would be that angle bisector. Some would argue even through the vertex, potentially. And it says, and also equidistant from 2 given parallel lines. So you got parallel lines. Equidistant would be that third parallel line midway between them. Maybe actually drawn so it looks parallel. And of course we see that if you went far enough, these two could intersect at one point. Maybe I go ahead and draw it this way so they do intersect at one point. We can actually see it. But we also, of course, could draw this in such a way that the parallels ran parallel to the bisector, in which case, of course, we could get no points. Or if the two parallels ran on opposite sides of the bisector, then we could get infinite points. And this is true no matter how big the angle is, right? Any angle is only going to get that one bisector. And since you have the freedom to position these lines however you want, these are your possibilities. How many had these answers on number 2? All right, questions from those who didn't. Which ones were you missing?
Instead of one, I had 2. Getting confused about.
Okay, so yeah, so I think the problem there, I've seen students do this before, is they look at this line, the angle bisector line, intersecting these lines. Well, again, it's where the locus lines intersect, not the given lines. So careful there. Genesis?
Infinity.
You were missing the infinity. Does it make sense that you could also, just as you could run it parallel to mist, you could slide it over and make the parallel coincide. All right? Number 4 is an interesting one. Give it a shot. And then we'll take a look at it together. Number 4. Jamie's got it, Ethan's got it, Genesis got it, Quentin's got it. Let's take a look. Well, we have a triangle, right? We're finding a point on one side of a triangle that's equidistant from the other 2 sides. And if you're not careful, you look at this and you'll say there's only one locus. But there's 2. The first locus is on one side of a given triangle. So you start by drawing some triangle, any triangle, really doesn't matter which, and you pick one side of the triangle. That's my first locus. Not that line infinitely, by the way. Only that segment, right? And then it says, so that's locus number 1. Then it says also equidistant from the other 2 sides. Have I memorized that one? Yes. Because what do the other 2 sides form, class? An angle. And what is equidistant from the sides of an angle? Angle bisector. So I'm going to draw the angle bisector. How many points, class? 1. Right there. Any other possibilities? Could the angle bisector ever miss the opposite side? No. A perpendicular bisector could, by the way. If you had like some weird looking triangle like this, and you constructed a perpendicular bisector, it hits one side but it doesn't hit the other, right? So we could miss one side, but an angle bisector has to hit the other side. Could the angle bisector ever coincide with the opposite side? Nope, could never coincide. So your only answer is 1 point. How many had that? Okay, a couple of you did. Questions from the rest of you? All right, do you see how you've got to think a little outside the box of triangle? 2 sides makes angle. Oh, equidistant from the sides of an angle is an angle bisector. Let's do number 6. Number 6. This is an interesting one to try to understand. Some students struggle in envisioning this. It says, find the locus of the midpoints of all lines drawn from a given point to a given line. Well, you realize you could draw a line here, 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 a line way out here, a line here. How many lines could I draw, class? An infinite number. But it wants to know the locus just of the midpoints. So for instance, midpoint. The midpoint. Midpoint. You get the idea, right? What would be if I drew all the midpoints? What would I get? Yeah, I get those 2 answers, is semicircle and straight line. Well, here's the deal. Is this distance going to be the same as that distance? No, because each line gets progressively shorter as it approaches the perpendicular, right? So they would not all be the same distance from this point. The distances from the point would vary, wouldn't they? So it couldn't be a semicircle, because that would have to have equal distances all the way around. But although the distances from the point vary, the distance from the line would be the same. So we would get one straight line parallel to the given line. Now, technically, it wouldn't be a full line, it'd be a line segment bounded by the very last line here. So it would be that. In fact, it would be specifically what line? The no-name line, wouldn't it? The no-name line would be our locus here, because that would be joining the midpoints of those ends and running all between. It would be parallel to this line here, and of course half the distance from the point of the line away from the line. But kind of an interesting one there. That was not compound, was it? Because there was only one locus the whole time. It wasn't an intersecting locus problem. And number 8, also not an intersecting locus problem. It's just a simple locus problem, just to mix it up on you a little bit. Take just a moment to take through number 8, and I'll go over it for sake of time. Equidistant from 2 concentric circles. Would this point be equidistant from those 2 circles? No, it's clearly closer to the small circle than it is to the big one, right? Would this point be equidistant? No, it's still closer to the small one. Would this point be equidistant? No. To be equidistant, it really just right in between, right? But that's not the only point. We could get more points. And if we did, we would get, class, a circle. Tell me about the circle.
It's between the 2 concentric circles midway.
It is midway between them. But with a circle, remember, I need to know about a point and I need to know about a radius. What's the center point going to be? The same as the given center, right? What's the radius going to be?
First given radius plus halfway.
How would we get something halfway between the first and second radius? There's a word for that. The average. It would be a circle concentric with the other two, having a radius equal to the average of the two radii, right? R1 plus R2, but then divided in half. So anyway, kind of a fun one there. Had looked at a basic locus and want to look at that as well. No homework this evening. Do want to make sure that you know we're going to be starting more constructions next week. So make sure you have compass and straight edge with you on Tuesday as we get ready to resume constructions. Because understanding loci allows us to think through constructions. Constructions where I don't teach you step by step, this is how you do them. You figure out how to do them based on your knowledge of geometry and the loci we've been learning. So it's a whole different type of construction section coming up that'll stretch your brain. It's like doing proofs, but not listing out statements and reasons, doing the proof in your mind and making it come out in a picture on paper. Excited about that coming up next week. No homework this evening. Have a wonderful rest of your day.